Hello students, in this video I will explain about binary search. So binary search is another technique of searching any element in the array. So some points you need to remember in case of binary search. First point is that the array must be sorted. Sorted means it should be arranged either in ascending or descending order. So it should be in ascending or descending order. Okay, then only we can apply binary search. Next point, in this case we don't go and check each and every element present in the array. The array is actually divided into two halves. Okay, two halves, and then the element is searched, which will be obviously based on some condition. So let us see how we can apply binary search. So I am not writing the entire program, I will write only the conditions. As you already know that how to enter elements in an array, so let us suppose we have already entered an array which consists of some 10 elements. So let us put the index numbers. Let the name of array is A. Okay. Okay, let the elements are 11, 22, 33, 44, 55, 66, 77, 88, 99 and 111. So as you can see, I have taken the array in ascending order arranged elements. Now let us take the number that I want to find. Let it be ns, the number I want to search, and let the number is 88. Okay, it is present, you can see here. So how you will write the logic for this? So for writing the logic, we will take some more variables. Those variables are the lower bound, or you can say the lower limit. Let it be L. This L will always representing the very first index number, that is 0. Similarly, we will take U. This will be representing always the highest index number. So here I will write the logic for the program. Int L is equal to 0, U is equal to 9, and one more variable I will take as mid. Like the previous linear search, I will take T, the temporary variable. Okay, now we have already entered the array as well as the number to be searched, so I am not writing the entering values part, only the logical part. While this L is less than equals U, till this condition remains true, this loop will run. So now first thing we have to find the mid value. So mid, we will write L plus U divided by 2. Okay, now you can see here L value is how much? 0. So L is 0, U is 9. So 0 plus 9, 9 by 2, how much? 9 by 2 is actually 4.5, but since we are taking as integer, so only 4. So we will get mid value as 4. So this position, this index number will be the mid position. Now you have to check that whether your element is present in this part or else in this part. For that you will write or exactly at this position. So 3 conditions will be there for this. So first we will write the first condition to check whether this element is present in this part. If it has to be present in this part, the condition will be like if ns, that number we have to search. So if ns is less than a of mid, it means that ns less than, see ns value is how much, 88, less than a of mid. A of mid means 55. It is not less than mid position value. If suppose I am not finding 88, I am finding 22. In that case, so it is correct. So if that is the condition, I don't need this part. So for that I will omit this. So to omit this, what you will do, you will write that the u value will become mid minus 1. It means suppose you are finding this 22. So 22 is less than 55. Why? I will search in this part. So I have to remove this part. So for that it is written u equals mid minus 1. In that case u will become how much? Mid position is 4. So 4 minus 1, then this will become 3. Now second option is if ns is greater than a of mid. It means that I am searching in this part. So my value was ns is 88. So is 88 present in this part? Yes. If that is the case, what we will, similarly we will shift this L to mid plus 1. So L will become mid plus 1. Okay. Then the last possibility is exactly in this position. So for that I will write if a of mid is equal to ns. In that case this t will become 1 and it will break the loop. I hope you still remember why I am using t. This is just a temporary variable to come out of the loop in case the number is found. Remaining part will be same. If t is equal to 1, you can print the number is such successful number found, etc. Only you have to focus about this logic. Now see how this logic works. As we have already seen that 88 is greater than 55. Okay, it means this second condition becomes true for us. So L will become mid plus 1. Now see, L will become mid plus 1. Mid value is how much? 4. You can see here. Okay, so 4 plus 1. So L will be 5 now. So where this L will shift? Now L will shift over here in this position. So I don't want this part now. So this part is not required anymore. Now we have got a new L value. U is still there. Now once again it will go back to the beginning of this while, and here it will find once again the mid value. So now L value is how much? L is 5, U is 9. So mid will become 5 plus 9. 5 plus 9 and divided by 2. So 5 plus 9, 14 by 2, that is 7. So you can see the array, this 7, this position will become the new mid. Once again it will check the condition from the beginning. So now the first condition is ns less than a of mid. Ns is less than a of mid. Ns is how much? 88 is 88. What is the value present in the mid position? 88. No, this condition is false. Second condition, 88 greater than 88, still also false. 88 is equal to 88. Yes, it is true. So you can see the number is found. This t will become 1 and it will break the loop. This is how this binary search works. There is a possibility that the number is not present. In that case, these all conditions will remain false, and till this condition is true, the loop will run, but at last the t value remains 0 only. Okay, so in the next video I will explain the selection sort program.